Have you ever wondered how satellites work? What are space debris? What are the different orbits and many more? Hello everyone. We are super excited to present a brand new podcast series by Assiduous City. In this journey, we will take you deep into space science and put an end to all of your doubts. So let's get started. Do you know? Around Earth there revolves a giant ball of rock, 3,476 kilometers in diameter and 7.3 into 10 raised to the power 22 kg in mass. Yes, it is nothing but our moon. Have you ever thought of how the moon manages the excellent job of not colliding with the Earth despite Earth's gravitational pull? In the same way, why don't these satellites fall out of the sky? By this time, you all might have guessed the topic. Today we are going to learn how do satellites orbit the Earth. So without wasting time, let's get into the topic. What happens when we throw a ball at a height of few kilometers from the Earth's surface? It will fall gradually, won't it? Then how do these satellites and moon revolve around the Earth without falling back? Let's go with a small experiment called Newton's cannon thought experiment to study the motion of the satellites. Before starting the experiment, assume that there is no air resistance and also we have a magically powerful cannon at a height of more than 100 kilometers. When we fire the cannon horizontally, it reaches a certain distance before falling to the ground. The faster you fire the cannon, the further it goes before crashing on the Earth. What if we could fire the cannonball at an unbelievable speed of 8 kilometers per second? The cannonball is locked into a speed that is fast enough to defeat the downward pull of gravity. It would follow the curvature of the Earth being pulled towards the Earth by gravity, but it will never reach the ground. This is exactly what happens with satellites orbiting the planet. Satellites are sent into space by a rocket launched from the ground with enough speed to get outside our atmosphere. Once the rocket reaches its determined location, it drops the satellite in its orbit. The initial speed attained by the satellite as it detaches from the launch vehicle is enough to keep the satellite in orbit for hundreds of years. But how do we find the initial velocity and time period of the satellite? The velocity of the satellite can be expressed in a mathematical equation as v is equals to square root of g into m divided by r, where g is gravitational constant equals to 6.673 into 10 raised to the power minus 11 Newton meter square per kg square. M is the mass of the central body about which the satellite orbits, and r is the radius of orbit for the satellite. Similarly, time period of the satellite can be expressed as t is equals to square root of 4 into pi square into r cube divided by g into m. The satellite maintains its orbit by balancing two factors: centrifugal force due to the motion of the satellite and centripetal force, that is Earth's gravitational pull. A satellite orbiting closer to the Earth requires more velocity to resist the stronger gravitational pull. As the distance increases, gravitational pull gets weaker, so less velocity is enough. Satellites do carry their own fuel supply, but unlike how a car uses gas, it's not needed by a satellite to maintain speed for orbiting. It is reserved only for changing orbit or avoiding collision with the debris. Now, why satellites change their orbit? And what are the types of orbits there in space? Let's discuss them in our upcoming episodes. Stay connected till then. Thank you.